Previously, we talked about arithmetic sequences. If you recall, those are the sequences where we add the same number over and over and over. These are called geometric sequences, and geometric sequences are sequences where you multiply by the same thing over and over, and the amount you multiply by is called the common ratio, and we usually use the letter R to represent that. If you remember, with arithmetic sequences, it was common difference, and that was represented by D. But what we're multiplying by every time in a geometric sequence is called the common ratio, and that is usually symbolized by the letter R. So, just for an example of what they might ask, they might say write the first 6 terms given that the first term, that's A1, is 6, and R equals 1/3. Well, just remember, R is the common ratio, so that's the number you'll be multiplying by every time. So we start with 6, and we multiply by 1/3. So 6 times 1/3 is 2. Now we need to multiply by 1/3 again. 2 times 1/3 is 2/3. 2/3 times 1/3 is 2/9. Times 1/3 is 2/27. Times 1/3 is 2/81. So that would be the first 6 terms of this sequence. You just continually multiply by 1/3 every time. 6 times 1/3 is 2. 2 times 1/3 is 2/3, and so on. Okay, let's move on to the next example, see what else they may ask. Okay, this is actually just a formula. This is the explicit form, and this is on your formula sheet. It's on the right-hand side toward the top of the page under geometric sequences and series. It's the very first formula, and this is the explicit form. So anytime you're asked to find the equation for it, or if you're asked for a specific term, this is what you'll want to use. Remember, A1 represents the initial term, or the first term, and R represents what you are multiplying by each time. It's the common ratio. So if you're asked for the formula or for a specific term, this is what you'll want to use. So we have an example here. Find the 8th term of a sequence with A1 equaling 4, so the first term is 4, and R equals -2. So if I wanted to, I could actually just multiply by -2 7 times to get to the 8th term. Or, what might be a little quicker is to use this formula. So I'm looking for the 8th term, so I'm looking at this formula right here. 8th term, I plug in A1, that's the first term, is 4. I plug in -2 for R, and I'm looking for the 8th term, so I plug in 8 for N. So then we can use the calculator, plug that in, 4 times -2 raised to the 8 minus 1. Oh, 1 second, sorry, I need some parentheses there. You obviously could just type in 7 for the exponent if you want to. We get -512. So the 8th term in this sequence would be -512. So once again, the formula that I have outlined in blue there is good for two things. It's good for if you want to if you're told to find the formula, the explicit formula for a geometric sequence, or if you are looking for a specific term in that sequence. Okay, now here's something else that you may be asked to do, and that's to find the sum of the first 18 terms, or however many terms. This is just one example. But if you're asked to find the sum, then there's 2 routes you can go. The first, which is the one I would recommend, is using sigma notation. Okay, so if we use a sigma in combination with our formula up here that's in blue, we can do this pretty easily. We say, okay, sigma, and I want to do the first 18 terms, so I would start at 1 and go up to 18. So that'll do 18 terms. And then I just plug in my formula. So I'd do A1, which in this case is 2, times R. Okay, so let's stop a second and see what our R is. What are we multiplying by every time? Well, the good news is if you know it's geometric, you can really just look at the first 2 terms. You just say, okay, what is 2 times what gives me -8? Okay, well clearly that's -4. And you can double check if you want with the others. -8 times -4, that is +32. So that's it. That's what we want. So I plug in my common ratio for R, what I'm multiplying by every time, and then I just put N minus 1 up here because I want it to count each one of those different terms. So then you can use your calculator. And recall in this some of your calculators you have a summation. On this one I don't, so I have to use second list, go to sum, second list, go to sequence, and then I plug in the equation, 2 times parentheses negative 4 raised to the parentheses x minus 1. And then I close the parentheses, do comma x, or my calculator is using t right now. That's fine, as long as you use the same variable all the way throughout, it doesn't matter. And then we go 1 comma 18. And so we get a rather large negative number. That's something like negative 27 billion, if I'm not mistaken. So we get a large number for the sum of this sequence. So I'll just write negative 2.748 times 10 to the 10th. I think I rounded up to 9 actually would be correct. So like I said, that's somewhere in the neighborhood of negative 27 billion. So it's a rather large sum, large negative sum anyway. So that would be my recommended way. But if you look at your formula sheet over on the right hand side under geometric sequences and series, you'll also see this formula, the one up top here. Okay? So don't worry about the recursive form right now, but we'll use this formula. And this one's completely good. There's nothing wrong with it. For me, it just is more consistent to always use sigma when we're looking for the sum, but this will work as well. So for the previous example we just had, let's look down at that again. Okay, our A1 was 2 and our R was negative 4. So let's look at that. So our A1 was 2, our R was negative 4. And then N is the number of terms. N is the number of terms you're trying to find. So we're doing the first 18 terms, so I'd plug in 18 for N. Then I'd do 1 minus negative 4 on the bottom. So if you watch, and I plug this in the calculator, I'm going to get rid of those T's. There we go. Now it'll be X's again. 2 times 1 minus parentheses negative 4 raised to the 18th, all divided by parentheses 1, well it really is plus 4 since it's minus a negative. And if you look, I get the exact same result. So that's just two different ways to accomplish the same thing. That's two different ways you can find the sum of the first certain number of terms in a geometric sequence. So that would be basically a geometric series. Now the last thing I wanted to show you is just the recursive form. The recursive form is very simple. You would just plug in whatever your first term is, and then you just plug in your R. So for example, on the one we just did, the recursive form would be A1 equals 2, and then AN equals negative 4 times AN minus 1. So the recursive is very simple. Just put your first term in, and then multiply by your common ratio.